Tēnā koutou katoa. Me mihi ka tika ki ka takata whenua o Aotearoa. Ko Aotearoa te Taraka waiwai. Ko Ōtepoti taku kaika anaenai. Ko Kati Pakiha ahu. Ko Alison Cree taku wikoa. Greetings. I've just introduced myself with a few words of Te Reo Māori, and this is one of the official languages of New Zealand, and I've said that I'm from New Zealand. New Zealand is my place of belonging, and I've expressed a greeting and respect to the Indigenous people of New Zealand. And I've said that Dunedin, or Ōtepoti, is the city where I now live, and I'm a New Zealander of European descent, and my name is Alison Cree. Thank you very much for having me speak with you tonight about Te Hokinga Mai, the return home, or more specifically, the return of Tuatara to the south of New Zealand to a site called Orokonui Ecosanctuary. Before I get onto this topic, I'll say a few words about where I live and the city of Dunedin, and a little bit about my herpetological career. So here is Ōtepoti, or Dunedin, at 45 degrees south in the southern South Island of New Zealand. It's halfway between the equator and the South Pole, and it's a cool temperate climate, very changeable. And yes, that is snow in the right foreground. This was a photo taken just a week or so ago in early September from Mount Cargill, one of the hills just slightly to the north of the city. The University of Otago has some beautiful old bluestone buildings in the central part of campus. I'm in the Department of Zoology, which has this building shown here, and to the right of it, a newer building, which is also part of the department. I've been here since 1991. But my career in herpetology in New Zealand began in the early 1980s when I was an honours student at the University of Canterbury in Christchurch. And there, for my dissertation, I compared aspects of cold tolerance and water balance in two Australian frogs, the southern bell frog, which I understand is now called Rhynchocephalian rhiniformis, and the whistling frog, Litoria ewingi. And after that experience, I continued my work in ecophysiology with a doctorate at the University of Waikato. And there I studied the live palmatid frogs in New Zealand. This is a very distinctive lineage, a family found only in New Zealand with 3 living species. And I was very fortunate to study them and be able to compare the 2 terrestrial species, Archie's frog and Hamilton's frog, with the semi-aquatic Hochstetter's frog, and to be able to show that there were differences in the way the skin reacts to a hormonal response during dehydration that assists with the terrestrial frogs being able to live in that more desiccating environment. After that experience, I was very fortunate to join Charles Doherty's research group at the Victoria University of Wellington. And as I was a postdoc there, and I'm working alongside Mike Thompson from Australia, who was also a postdoc. And yes, we all had a lot more here in those days. We were working principally on the island Takapo-Rewa, also known as Stevens Island in Cook Strait, and we were working with Tuatara. This was my first introduction to work with reptiles. And the population there is extremely high density and a marvelous outdoor laboratory for studying this very special species. It's one of the islands that have remained free of introduced rats, which is why we find so many Tuatara there. All told, there are about 32 offshore islands shown by the blue dots. Some of those dots cover more than one island where Tuatara have survived, though we know they would have been present throughout the North Island and much of the South Island too, when humans first arrived about 800 years ago. My work was on the reproductive cycles of the males and females, and after that wonderful experience, I would like to introduce the study species here. The Tuatara is, of course, a reptile that looks like a lizard, but it's not an agamid dragon. It's not even a lizard, it's a rhynchocephalian. So a last representative of that order Rhynchocephalia, which is the sister group of the squamates. And importantly for New Zealand, this is the only place where rhynchocephalians survive in the world. The other lineages, the other representatives in the lineage having become extinct some tens of millions of years ago. The name Tuatara is a Māori word. It's the same in singular and in plural, and it refers to the peaks on the back of the animal. They're more distinctive in males than in females. My main photo here is in fact a female. You can see here in the male that the spines of the crest are more prominent. They're surprisingly soft to the touch. Many people are surprised by that. And they can be erected, particularly during interactions between animals, such as during the mating season. Females are smaller than males, females up to about 500 grams in the largest bodied populations, and males maybe 800, 900 grams, maybe even a kilogram in the very largest specimens. So these animals are very distinctive to New Zealand. I mentioned they're the last surviving rhynchocephalians, so they have differences in their skeleton and their soft parts and their genes compared with squamate reptiles, but they are each other's sister groups. And it's about 250 million years ago since the rhynchocephalians and squamates last shared a common ancestor. And some of those differences are in their skull and the teeth and jaws in particular, and affect the way the animals feed. Tuatara, also a very long-lived species, and specimens are thought to be up to about 100 years with study that's been carried out in the wild so far. Tuatara are an animal of great distinctiveness and importance in New Zealand. I mentioned they're named by Māori, and they continue to hold an important role as taonga or treasures, and they're reflected in oral traditions and in some carvings of the Māori people. And they're also important in identity for New Zealanders as a whole. They've been shown on stamps of New Zealand. They were on a coin, the 5-cent coin shown there, until it was withdrawn in 2006 because it lost most of its value. So very distinctive animals. Only place in the world where we find rhynchocephalians surviving today is in New Zealand. So it was a wonderful opportunity for my postdoctoral research to be able to study the reproduction of this distinctive animal. When I came to my first position as a lecturer at the University of Otago in Dunedin in 1991, I thought I was leaving behind the opportunity to study wild tuatara, unless I travelled a great distance, and I turned instead to the lizards of the Otago region. We have some wonderful lizards in this area. These big open skies of Otago have some wonderful rock outcrops and grasslands where we find species such as the Otago skink, shown on the top right, in the genus Oligosoma, and some species of geckos as well, such as the Woodworthia, shown on the bottom left. And the geckos are particularly interesting because, of course, they're live-bearing geckos, which is very unusual for geckos worldwide. And like tuatara, are very tolerant of cold temperatures and with slow life histories. And some of these geckos are known to live several decades in the wild, which is very impressive for such small-bodied lizards. And some of them also have pregnancies lasting more than a year. So as I mentioned, I thought, being based in Dunedin, that I was not going to be able to study wild tuatara unless I travelled large distances, but there was an opportunity that arose through the vision of other people who looked at things in a different way. So the bottom viewpoint is looking south towards Dunedin. If I turn around and take a few steps and look the other way, we can see a valley called Orokonui, and that's where this place, the Orokonui Ecosanctuary, has been established through the vision of people who in the early 2000s could see the potential for creating a site where introduced mammals, these big problem species for New Zealand, had been eliminated. So the vision was to create an ecosystem free of introduced mammals and with indigenous species appropriate to coastal lowland forest of the East Otago coastline. And it wasn't just an ecological vision, it was a vision where people could enjoy a peaceful encounter with nature and gain inspiration in various ways, including a new commitment to conservation. And the vision grew and got support, and funding was obtained. A wonderful visitor centre at the top of the valley was created. And by about 2008, the fence that's an integral part of the eco-sanctuary to keep out these problematic mammals that have been introduced to New Zealand was established. So the fence is made by a company called Excluder. It's almost 9 kilometres long. The eco-sanctuaries are just over 300 hectares in area. It's got a mesh that keeps out the mammal species and a hood at the top to stop them climbing over. And as is being shown on the photo on the left, there's a skirt hidden under the ground that stops animals burrowing in from the outside. This group of people is members of SRANZ, the Society for Research on Amphibians and Reptiles in New Zealand, who are paying the site a visit. And there has to be a way for people to get inside because this is an eco-sanctuary for and by people. And this photo shows my husband and some overseas visitors coming in through the visitor entrance gate. And many people are involved in not just visiting, but helping the eco-sanctuary actually achieve its goals as volunteers and others. So the fence I mentioned is integral. Here are some photos to demonstrate the pressure from outside on the photos on the left. These are photos taken by a master student in my group, Jemima Gardner-Rodden, who was studying Tuatara. But the photos, by chance, demonstrate some of what is being kept out. And also the fact that the fence allows the reintroduction of highly vulnerable native species, such as the kiwi, a species called the Haas-tokaweka on the left-hand side, inside the sanctuary, a cat watching from the outside. This particular photo generated quite a bit of publicity when it was released on the Ecosanctuary's Facebook page. A photo in the middle showing, I believe, a rat climbing the fence. Of course, it won't be able to get over the top because of the hood. And if your eyes are very good, you may be able to work out what's in the photo on the right, which is in fact an Australian whistling frog climbing the fence. Whistling frogs are present in the eco-sanctuary, and so far nobody's worked out a way of eliminating them. Of course, they're not native to the area, but they also don't seem to be doing obvious damage at present, so they stay for now. The operation of the eco-sanctuary depends on a huge number of people. One person with whom our group works closely is Elton Smith, the conservation manager on the left, but there are other staff who are rangers and work in other ways in education with schools who visit and so forth. And then there's a huge effort by volunteers who contribute to the operations of the eco-sanctuary with weed control, with revegetation, and in many other ways. This photo here just shows a group of the local community celebrating the closing of the fence in about 2008. So the existence of this fenced eco-sanctuary raised for me the possibility of re-establishing Tuatara in this area. But to proceed in this direction, we needed to be able to show that it was appropriate to have Tuatara as part of the local ecosystem. I'd been working on a book about Tuatara during this time, and I knew from the work of paleoecologists like Trevor Worthy and others that there were remains of Tuatara that were from natural deposits. This map is taken from my book, and the red diamonds show where there's evidence of Tuatara remains from natural deposits, such as the remains left by predatory native birds before humans arrived, or where Tuatara have fallen into caves. And we can see that there's a site with a natural deposit only about 40 kilometres from Orokonui, and further up the east coast as well. And there's a site where a Tuatara bone, such as the jawbone shown in the photo at the bottom, has been found in a midden. That's a human rubbish tip from the Polynesian times of settlement, and that's very close to Orokonui. From this sort of evidence, and also from species distribution modelling that Scott Jarvie in our research group has completed, showing that the climate of the East Otago region is suitable for Tuatara, we've proceeded with arguing that it was appropriate to reintroduce Tuatara to the eco-sanctuary. Of course, we needed to show that the local site had suitable habitat, and these photos here show the diversity of vegetation. There's some remnant forest, that's regenerating forest. Nikki Nelson is a Tuatara biologist from Victoria University of Wellington on the left, examining some of the habitat. And there is obviously still introduced species of plants being controlled, but there's plenty of edge habitat, which we know from experience elsewhere, Tuatara are quite capable of making use of. And so we felt that there was suitable habitat to proceed with a reintroduction, but we acknowledge that, as with many mainland eco-sanctuaries, there are no longer the seabirds that would once have brought a lot of the productivity of marine ecosystems to the terrestrial ecosystem. And that means we wouldn't expect to get such high densities of Tuatara in this habitat as would be the case on offshore islands with no rats and plenty of seabirds. We did need to acknowledge that Orokonui was much cooler than the nearest available source of Tuatara, which were found now, after human arrival, only in Cook Strait. But some important work was carried out by Anne Besson, a PhD student in our group, and Anne's work showed that if you put juvenile Tuatara in cooler conditions than they experience in Cook Strait, more similar to Orokonui, then they would actually continue to thermoregulate and do so more effectively, so they wouldn't just give up on thermoregulating. They also had similar preferred body temperature and critical thermal minimum to lizards from the local climate, so that critical thermal minimum refers to the body temperature at which they lose the ability to right themselves. And we knew from previous work by others that temperature-dependent sex determination existed in Tuatara. There's an FM pattern, which means cool soil temperatures produce females and warm temperatures produce males. And the monitoring that Anne did, along with Kathy Nottingham, a summer student, showed at Orokonui that there were some soils that were warm enough to have the potential to produce males as well as others that were cooler and that would produce females. So that was important reassurance. And then further reassurance came from the rearing of captive juveniles in an outdoor enclosure at Orokonui prior to their free release. So these were animals that had come from Anne's prior research at the university, and we showed that they could survive being in the outdoor climate at Orokonui. And furthermore, when we took measurements, this work was led by Ricardo Mello as a postgraduate diploma student in our group, working with eco-sanctuary volunteers and staff. And he showed that the growth rates were acceptable for Tuatara in this area, in fact, similar to what they would be in the wild elsewhere. So we felt that we had a case to bring Tuatara from Cook Strait to Orokonui from a biological perspective, but we need to ask, are animals available on that island, and will there be support to remove them? Genetically, the population on Takapō Rewa, where I'd worked for my postdoc years, was seen as the most suitable, and Tuatara are also highly abundant there in their tens of thousands. The local people in the area, Ngatikawata, and that the local iwi or tribe of the Māori people in that area. Ngatikawata identify strongly as kaitiaki or guardians of tuatara from Takaporewa. I can't speak for Ngatikawata, but my understanding of this concept of kaitiaki-tanga or exercise of guardianship is that it's an intergenerational responsibility. And that means that if tuatara move out of the area of Ngatikawata, it doesn't mean that the responsibility to remain concerned for and responsible for those animals is lost. So as researchers here in Otago, that means for me, it's been really important to maintain a strong relationship with Ngatikawata, to be supplying information on a regular basis, and to continue to communicate and consult about ongoing work and provide updates on how the tuatara are doing. And as the photo suggests, we did get support to bring tuatara from this area, and we have here two of the young members of Ngatikawata escorting the tuatara to bring them to Orokonui. We needed support to receive them from the local people. Katihui Rapa, Runaka, ki Taraki are the local people from the wider Ngaitahu iwi, and they gave a very warm welcome to the concept of bringing the tuatara here. And we also, of course, had steps that we had to meet to satisfy the New Zealand Department of Conservation that we had a sensible plan for bringing tuatara and that met the standards of the National Tuatara Recovery Plan and translocation proposals generally. And I'm really pleased to say that all of those steps were accomplished, and with widespread support, the tuatara from Takaporewa were brought south by the people of Ngatikawata, who are included in this photo taken near the release area, and handed over to the care of local people. And it was a great event, very emotional. And then we put the tuatara in the burrows that had been prepared for them and left them, and then thought about coming back and monitoring them. Because of course, being able to show that they survived the transition is really important. So I'm going to turn now to some of the results that have come from our research group, and I'm going to focus on the monitoring of that first major release cohort that was made in 2012, and it consisted of 15 adults, 15 adult males, 15 adult females, and 57 half-grown juveniles. And the juveniles came from 3 source groups. Genetically, they all whakapapa back. They have lineages that go back to the Takaporewa genetic stock, but some of them had been raised in captivity. The juveniles were studied by Scott Jarvie. Tackling juveniles, I'm sure you realise, is going to be challenging because they're often more cryptic and smaller, less easily seen than adults. But Scott was up for the challenge, and to assist with the recovery of juveniles, he developed a backpack harness, a modified version of one that other people had used, and used temperature-sensitive radio transmitters on the harnesses to help follow the tuatara initially. The 3 groups of juveniles that were available for monitoring were as shown on the map here. So we had wild caught juveniles that came direct from Takaporewa or Stevens Island along with the adults. We had juveniles that were reared in the outdoor enclosure at Orokonui. So we call those the Head Start locals, HS local. Head starting is a procedure for rearing juveniles beyond what is thought to be the most vulnerable part of their early years to release them at a larger size. And it's been quite widely used in prior translocation work with tuatara in New Zealand. And we also had access to another group of juveniles that had also been head started, but in the warmer climate of Ngā Manu Nature Reserve near Wellington. So these 3 groups of juveniles came south. They were half-grown juveniles, several years old, and Scott set about monitoring them. They, of course, do come out at night, so some of the monitoring is done with headlamps at night, but to get a high enough recapture rate, it was essential to have other approaches. There were the radio transmitters on a subset of the juveniles, and then another approach that Scott developed with great success was the use of a burrowscope. These are being used for seabird monitoring in studies elsewhere in New Zealand, and Scott found this worked really well at recovering juvenile tuatara, whether or not they were in the artificial burrows, as shown in the top right, which is made of a drainage pipe buried in the soil, or whether they're in natural burrows made themselves. So the flexible tube goes down, it's got a camera at the end with a red light, and it displays on the wireless display unit that Scott's holding in his hand the image that the camera sees inside. And if you're lucky, as was the case here with Noella McGregor from Ngatikawata showing success, we can find a tuatara inside and gently persuade it out. The photos taken of the display screen of the wireless unit. So with these kinds of approaches, Scott was able to compare the performance of the three groups of juveniles over their first year. They had their transmitters on, the subset had the transmitters on for the first summer after arrival, and then we had to take the transmitters off, and the recaptures after the first winter were dependent on the other methods like the burrowscoping. And it's really pleasing to note the very high survival that was evident from the ones with transmitters. Almost all of them survived their first summer, and then after the first year, we still recovered quite a lot of those animals. So for juveniles, that was, we felt, a very impressive result. And most of them stayed in their release area. Some of them continued to use the artificial burrows that have been provided. Some of them made their own. A few of them moved into slightly more open habitats. There were some differences in growth rate, which are shown in the graph on the right-hand side, but I'll start by saying that even in the slowest growing groups, they grew at least as fast as on the source island of Takapō-Rewa. So the ones that grew the fastest were the wild-caught ones that were brought south. And we surmise that they may have had some advantage in terms of being more efficient foragers and possibly thermoregulating to slightly higher body temperatures, as shown by the temperature sensitive transmitter data. And we suspect that that might be a short-term phenomenon, that as the head-started animals get more familiar with having to capture their own food, that difference might disappear over time, although that's just speculation. Based on these results, these encouraging results that Scott obtained, we were able to get permission to release a second group of juveniles, and this occurred in December 2016. And here's Scott showing one of them coming out of its transport tube, and to give you a better sense of the release process, I've got a short video here, and Scott will demonstrate the removal of the juvenile. These juveniles are about 4 years old. And it's going to be put into an artificial burrow. You see it's quite frisky. And there it goes into the burrow. And it might be some months or maybe some years before we see it again. So since Scott's work with monitoring the juveniles intensively over that first summer, we've continued to survey at night for recaptures, particularly from that first cohort that included adults. The data in terms of body condition, which we get from weighing them and expressing weight relative to snout vent length as a measure of robustness, is still being analysed for publication. But what I hope I can do is show you with a few summary points and some photos that they've been doing really well. So here are some recaptured animals. By 5 years after release, we shown that at least 60% of the adults had survived. We're not searching the whole sanctuary, we're focusing on and around the release area. So these are the ones that we recapture in that area, mainly. And the juveniles have also survived well, given that the estimates of minimum survival are lower, but still satisfying, and many of the juveniles have now reached adult size. Here are some photos, the two females on the top, an adult male on the bottom right, and a young animal that was released as a juvenile and is now just entering adult size range on the bottom left. The top photos are taken by Ricardo Mello as part of a study for testing photo identification in Tuatara. And this turned out to be quite fortuitous because although all the animals from that first cohort had been marked with pit tags for permanent identification, we opportunistically noticed that some animals, particularly some that were juveniles, when they were first marked before we received them, were losing their pit tags. And this was actually occurring some years after the release. So on the top left, we see an animal where the pit tag is coming out what we think was the original insertion site, suggesting that even 3 or 4 years after they're released, the skin may still be weak at that site and that the tag can eventually work its way back out. So Ricardo's work with photo identification, and he's shown in the bottom left taking a photo of a juvenile, was very useful, and we now have photographs of many of the animals as well. And Ricardo's work shows that it's possible to use some free pattern recognition software that's available on the internet to match animals. And this is with either photos of the right-hand side of the body, the head and the body excluding the tail, or the chest region, which often has very distinctive scale patterns as well as pigmentation, as shown by the animal in the top right. Moving on now to some of our more recent questions, we've been trying to gather information on whether the originally released adults are reproducing. Opportunistically, from trail camera footage, we have evidence of males entering breeding condition behaviourally. We can see crest erection, for example, in the animal in the trail camera photo on the left, and also in the capture from at night time of the animal on the right. The crest is fully erect in that animal on the right. And this is what we would normally see in males engaged in courtship or territorial disputes in the late summer mating season. You might notice that animal on the right also has blood around its mouth, and in fact, it was found within about 1 metre of another male, also with its crest erect, and both of them had blood around their mouths, and we think that they had been fighting, which is something that male tuatara do when their testosterone levels are high in the late summer mating period. They can also, I'll just jump back in here to show you something additional. They also vocalize at this time of year when the testosterone levels are high and they're competing, the males competing with each other. I don't have my own recording, but I do have this soft toy, this tuatara, which is one of a series in New Zealand that is sold as having authentic sounds. It certainly sounds authentic to me. So here is a male tuatara. So those, leaving aside the males, let's move on to the females. We always knew that female reproduction was going to be more of a challenge. We knew from the source population on Takaporewa, from several people's work, including my own back in the 80s, that only a small proportion of females nest each year. These are egg-laying reptiles. The X-ray on the left shows you a female that is gravid or carrying shelled eggs in spring, but only about 1/4 of the females will be in that condition. They also, when they're in nesting condition, they may move large distances, several hundred metres before they nest, so you won't necessarily find them nesting in their normal residential areas. When they nest, they lay a clutch of about 9 eggs, And once it's covered up with soil, it may be very inconspicuous, and the eggs will take a long period to hatch, potentially a year or a bit more. Only about half of them hatch, and the hatchlings are very rarely seen. So we didn't anticipate seeing much evidence of nesting without a lot of work. But having invested that work, led by Jemima Gardner-Rotten for her master's research, we're beginning to find that evidence. So there's Jemima in the top right, exploring a potential nesting site. On the top left, we have a gravid female that had previously been detected on trail camera footage as being actively digging, and it's just come out of that digging at night in that digital photo there, and has been palpated as gravid. In the bottom left is a photo taken by Jade Christensen in our group to show an excavation that was later filled with eggs and backfilled with soil by a nesting female. In the middle photo on the bottom row are 2 viable eggs. These would normally be covered up with soil. We've just brushed the soil off to reveal the presence of viable eggs in that site. And on the bottom right is Anne Besson holding the shell of an egg that we infer has hatched successfully from the very distinctive kind of split that we see in it. So over several years, we had evidence from shells that suggested indirectly that hatchling was occurring, but there's nothing like having the real hatchlings to prove the point. And here's Jade Christensen, who was on a Māori and Pacifica summer scholarship for undergraduate students, and Elton, both looking pretty happy with the fact that we've found some hatchlings this past summer. And Jade was the one who first discovered them. So this was pretty exciting news to be able to share with the Orokonui community and more widely in New Zealand just before we went into level 4 lockdown. In the bottom photo on the left, I'm taking a photograph of the hatchling on a rock, and the main photograph shows one of the hatchlings still with its horny shell breaker on the front of its snout. So there's some of the positives of the work that we've been doing. There have been some challenges along the way. With the fence as a whole, a very worrying period was when stoats got in. This has happened very rarely, but it's very significant when it does happen. And the fact that it has occurred means that it's been important to look at the design of the fence and the way pest monitoring is being carried out in the Ecosanctuary to minimise the chance of this happening again. Fortunately, the Tuatara seem to have come through unscathed. There are mice still present in the Ecosanctuary, and they're controlled to low densities, and so far there's no evidence of them causing harm to Tuatara, although we remain vigilant on that point. Unexpectedly, we had a breakout. One Tuatara was found outside, a gravid female, in January 2014, was found on the wrong side of the fence, having moved over 1 kilometre inside the Ecosanctuary. It had somehow got itself out. We don't know whether it was over the top or through a stream culvert, but again, this led to some rethinking and changes in the way the fence was, and the culvert gates over the streams were being managed. So, and no further evidence of any escapes. That particular female, there's no evidence she actually burrowed under the fence, but we have seen signs that females, when they're nesting, will be attracted to the fence line. Jemima here is showing with her hand how they can dig a little bit under the fence. As I say, there's no evidence they've ever gone all the way through. We think they nest fairly shallowly under the fence and then come out the same way. In the top right is a photograph of a site where the female did complete a nest before we got to it. If we find a digging under the fence, then of course we have to fill it in to ensure the security of the fence. So there's some positives from the work to date at Orokonui. I'd like to just step back now and give a bit of a national perspective on where Orokonui fits in. In terms of tuatara translocations, there have been a number to offshore islands, 10 in total since 1995, where tuatara have been moved from one island to another to re-establish them on an island that has been eradicated, where pest mammals have been eradicated first before putting tuatara back there. And there have been 4 North Island ecosanctuaries shown with the green rectangles around them, and Orokonui in the south is still by far the most southerly of these ecosanctuaries. So we see it as being important for that southern location, but part of a broader package of trying to re-establish tuatara in their homelands, although admittedly on scale, on the absolute scale, the areas involved are still small relative to the area that tuatara would have once occupied before humans arrived. And we've learned a lot from the experiences of the earlier translocations in terms of knowing how to do it, and that's been very beneficial for Orokonui. But let's also acknowledge that while some things have been going in the right direction, we humans are changing the climate globally, and this is a concern for all native wildlife. Here in New Zealand, the changing climate was brought home to us visually when in early January this year we had the experience of tobacco-coloured skies with the Australian bushfires, those catastrophic bushfires that you in Australia had to contend with. And although the sky has cleared of ash since then, the greenhouse gas emissions, the invisible emissions are still growing. And New Zealand has just experienced its warmest ever winter, as recorded by climate scientists locally. So I believe that we, all of us individually and collectively, have an important mission ahead of us to reduce our greenhouse gas emissions dramatically and rapidly if we're truly going to be preserving wildlife in the future. Tuatara, I would suggest, are at risk of rising sea levels in some of their low-lying islands up north, and also changing temperature and moisture have the potential to have harmful effects, amongst other things that could arise from climate change. I'd like to end now with a couple of thank you slides. First, I'd like to extend thank you to members of my research group from the university, the students who've contributed to many discoveries, and for all their hard work in the field and the use of their photos. Ngā mihi nui is a local expression in Te Reo Māori, thank you. So thank you to all of these people from the university, including Ken Miller for wonderful photographs. And a very warm thank you to everyone who supported the Orokonui project, including the iwi with whom we work, and all of the supporters, the sponsors and volunteers and staff and others who help run Orokonui Ecosanctuary and make it the wonderful experience that it is. Just on a personal note to reflect, back in the 1980s when I was a postdoctoral fellow working on Takapo Rewa, it never occurred to me that during my lifetime I would see wild tuatara free roaming in the South Island, let alone have the opportunity to study them. So it's been a great experience to work with local community in a way that's shown that that vision is in fact very much possible to achieve. Thank you.